angles of any magnitude. In a previous lesson, we decided that the definition of sine and cosine were as below. So cos theta, which is adjacent over hypotenuse, is just x over 1, which is just x, and it's the x coordinate of P, or a point. Okay, just this is how it's working on a unit circle. Same thing for sine, again, that's at a point on said unit circle. Okay, and now these definitions will actually apply to any angle theta of any magnitude. So it doesn't matter what the size of it is. So we're moving out of the right-angled triangles, so we're getting to angles bigger than 90 degrees. Okay, let's have a look at see how that works. So here we have a unit circle. We have, we'll just change this colour to, maybe use that dark green. Here we have our positive x-axis. And that's important to note because the positive x-axis is where all these angles are going to start from. Okay, it's where all the angles are going to start from. So I'm going to start here. I'm going to find a point in this first quadrant over here. There's a nice pretty point. And I'm going to join that up with a line that is the radius of our circle, our unit circle, which is 1 unit. Okay, and that's point P. Okay, now the coordinates for point P, all right, with an angle of theta, are just xy. All right, as we've used previously. Now in terms of trigonometry, we're going to give them a new set of coordinates, cos theta and sine theta. Okay, and this is going to work as we're moving around our unit circle. So I'm going to quickly pick another colour. I'm going to go with purple. Okay, and we're going to move into our next quadrant over. So remember, we're moving in an anti-clockwise direction. So I'm going to pick a point just over here. There's a new point P. And if I give that a nice little line, there's our 1. Okay, another point P. And this time the angle comes around like this. Like I said, it starts at that positive x-axis. The positive x-axis and moves around. So now we've gone past the 90 degrees, but our coordinates haven't actually changed in terms of x, y, cosine, or sine. So we still have x and y. There's still an x coordinate, there's still a y coordinate, which means there's still a cos theta and a sine theta coordinate. Okay, and this is going to work on the next angle as well. Alright, so we pop a point P just down here, an orange P this time. Coming down, again, it's still 1 unit. We still have an x and y, which means we still have a cosine theta, sine theta. And our angle now is coming right around, and we have theta there. Okay? And as you can probably guess, it's going to happen in our fourth quadrant exactly the same way. Exactly the same way. So we'll go back to blue and pick a point. There's a point, nice little point there. Again, just an x and a y, an x value and a y value because they are the axes, but we can replace those with cos and sine. So cos theta, sine theta. And then we can put in our little line, trying to get that at least a little bit straight. And coming all the way around for our value of theta. Okay, now that gives us some little bits of information. Okay, we know we now have range and domain because we're still working with functions. Okay, so we can make the following notes. Okay, so because minus 1 is less than or equal to x, which is less than or equal to 1, we can say that cos theta is from -1 to 1. Or we could say -1 is less than or equal to cos theta, which is less than or equal to 1. Okay, so it works the same way. We're just replacing that x with that cosine, and we can do the same thing for y. And we'll put that there. So same deal. So sine theta is now also from -1 to 1, or we have our little shortcut of -1 less than or equal to sine theta less than or equal to 1. Okay. Now we've established that, let's have a look at some other bits and pieces we can find in our unit circle in terms of trigonometry. If we go back up to our unit circle and make a point right here, call it A. Okay, it's on the x-axis, it's on the unit circle, point A. At A, we can say that theta equals 0 degrees. Because it's right on that x-axis, it's 0 degrees. It has coordinates of 1 and 0, because the x-coordinate is 1, y-coordinate is 0. And we can lead that off to say that cosine theta equals 1, because that's the x value. Sine theta equals 0 as the y value. All right, and that is for when theta equals 0. So just a reminder there, that's for when theta equals 0. We go back up to our diagram up here, and if I put a point up here for B, so I've got 90 degrees around for B, so I can say at B, theta is now 90 degrees. All right, so we've moved up that, we've made it perpendicular, 90 degrees. We're now at 0, 1, and that just means that we've swapped our values around. So cos theta is now 0, sine theta is now 1, for theta equals 90 degrees. Okay, so we can keep that going. We're going to keep going. We're going to put our C point in here. So there's C. All right, so at C, at C, theta is now, adding another 90 degrees on, is now at 180 degrees. We're at -1, 0 now. So that gives us the following values. Okay, so cosine theta is -1, sine theta is 0. And that is for theta equals 180. Okay, we're going to move on now. We go back up to our drawing, put in D. There's D. So at D, at that point D, theta is now 270. We've just added another 90 degrees. It's now at 0, -1. So same as before, we're going to swap those values around. For theta equals 270 degrees. All right, now what we can now do is we can go the full revolution. So we get back to A. In other words, we've done a full revolution. All right, so that means that we've got our full revolution. Theta is now 360 degrees. Okay, and then the rest is the same as A above. All right, it's the same as A above. And we can keep that going. We can go another 90 degrees around. So now we're back at B. Or back to B. we've got a full revolution around plus. All right, theta is now 450 degrees. So you can see there, we've even gone outside the confines of our circle. All right, but it's the same as B above. Same as B above. Okay, so 0 and 360, same values. 90, 450, same values. If I was to go 180 and the next one around, which is back to C again, which will be 540, they're going to be the same. Okay, and it just keeps going around that circle.